These are natural gas workers, dedicated, hardworking, resourceful. These are also natural gas professionals. Their clothes might be cleaner, but they are just as dedicated, hardworking, and resourceful. And like their more visible colleagues, they are well compensated for their efforts. All of these individuals represent the diversity of occupations required to produce a well. The result of their collective effort generates both praise and apprehension. Supporters of natural gas development believe its abundance and relative cleanliness compared to other fossil fuels make it an effective, environmentally sound way to reduce the country's dependence on foreign energy sources. Natural gas critics stress possible environmental consequences. They point to drilling's intrusion on the landscape and the negative impact it could have on air and water quality despite industry and governmental regulations. While those issues continue to be debated, there is a reality that both camps can agree upon. The natural gas industry offers rewarding career opportunities, especially for those with a technical skill set.
I didn't learn about it until my senior year of college. I just kind of heard it in passing. I had a friend up one weekend and I was trying to get him into a hotel, and we couldn't get him into a hotel because they were all booked. Well, it turns out because of the gas industry. I said, well, what gas industry? What is that?
Doug Martin now knows what the gas industry is. He lives it every day as an automation technician.
I love going out there and beginning with something that doesn't work and working on it and putting my sweat and hard work into it and actually coming up with a real result, saying it wasn't working and now it is.
Doug is responsible for monitoring the readings at well sites throughout a 3-county area in north-central Pennsylvania for Anadarko Petroleum Corporation, one of the world's largest independent oil and natural gas exploration and production companies.
I deal a lot with communications. Since all of our well sites are remote locations, there's no real conduit for communication. So it's mostly cellular modems or satellite dishes that communicate what our values are on site back to our office, which we can view through our software to see what our values are. Signet is our software that we have here in the office that takes all the information that we have out in the field and brings it into the office through the software so we can see what pressure we have on this well, what temperature we have on this inlet valve, which valves are open, how much water we have in our tanks. It tells us all the key information that we need to know that makes sure that everything is running safely, that wells are producing properly.
According to the Pennsylvania statewide Marcellus Shale Workforce Needs Assessment, 85% of all jobs in the gas and oil field require training or education beyond high school in the form of specialized certifications, 2-year technical degrees, baccalaureate degrees, or graduate work. A majority of natural gas employers surveyed say a lack of technical skills is one of the biggest challenges they face in finding workers. Doug obviously possesses those skills. His fascination for electronics dates back to high school when he chose it as an elective.
I just arbitrarily picked electronics thinking, well, that might be something I like, because I liked fixing things. I liked knowing how things worked, how things were built. So I continued on for the second and third courses, which I ended up really enjoying and found that that was something that I may have wanted to do with the rest of my life.
Doug obtained a bachelor's degree in electronics engineering technology at Pennsylvania College of Technology. He worked in the field as an electronics technician before joining Anadarko in his present role.
Some of the other jobs I've held in the past were definitely just jobs, but it's kind of, I knew as soon as I walked in this door, this was definitely a career choice.
A career choice that demands tremendous responsibility.
It's critical that that instrumentation is working properly, especially for our safety systems, because a lot of our instrumentation is geared towards those safety systems. And I come in with my laptop and I log in and view these things. So I'd say maybe an hour, maybe 2 hours of my day are spent in the office most mornings, when majority of my time is spent out in the field where all the action is, where everything needs to be fixed or needs to be maintained.
Soon, Doug will be in the field to troubleshoot, there is a lot of instrumentation to review throughout north central PA on this spring morning. In its purest form, natural gas has no color, shape, or odor. What it does have is power. It's responsible for approximately a quarter of all energy consumed in the United States. And that's expected to increase. The U.S. Department of Energy predicts natural gas consumption will grow 11% by the year 2030. Natural gas is a mix of hydrocarbon gases. It consists primarily of methane and occurs naturally underground. Natural gas has been extracted for more than 150 years. For much of this time, technology limited exploration to so-called shallow gas, typically porous rock deposits located just beneath the Earth's surface. There was no way to access the vast natural gas reservoirs trapped by shale thousands of feet below ground. Shale refers to dense, sedimentary rock formations that have formed over millions of years.
So we're talking about very small micropores that are actually embedded or encapsulated in the stone, and that's what has to be broken open to allow pathways for the gas to actually escape.
Thomas Murphy is co-director of the Penn State Marcellus Center for Outreach and Research, an entity at the university devoted to shale gas development. He is also a founding partner of the Marcellus Shale Education and Training Center at Penn College. The center provides workforce needs assessment, new technology development, and customized training for the oil and gas industry.
I've been working as an educator, an outreach educator for more than 25 years, and this certainly is the most interesting and certainly the most exciting years that I've spent, the last 5, 6, 7 years here working and seeing this development occur here in Pennsylvania.
Advancements in technology have led to a shale gas boom in Pennsylvania and throughout the world. Government research and private investments have generated innovative techniques, such as horizontal drilling and hydraulic fracturing, to capture natural gas from shale. Typically, a well is drilled for thousands of feet until it intersects with shale, usually located more than a mile below surface. Once shale is reached, the drilling sweeps horizontally into the formation for the well bore to intercept more shale and increase the yield of the well. This process can take a few weeks. Next comes hydraulic fracturing, a high-pressure injection of millions of gallons of water, sand, and chemical additives break apart or fracture the shale to release the gas, which then flows back to the surface in the well casing. While the hydraulic fracturing process itself takes only about 10 days, the result can be a gas flow lasting decades. The Energy Information Administration projects that shale gas will represent nearly half of all U.S. natural gas production by 2035. Professionals are needed to exploit shale plays throughout the country. In the Northeast, the Marcellus Shale is under parts of 6 states, including 2/3 of Pennsylvania.
Most companies are looking that there's likely enough gas here to last when you think about the whole area. The whole Marcellus footprint, likely to be looking at somewhere bumping 20 years worth of gas. But when you start to combine that with other shale plays in the country, we're looking at 100+ years of gas over time. So it's a lot of gas no matter how you look at it. And one thing we should illustrate right now is most of the jobs that are affiliated with the development of natural gas are not necessarily on the drilling rig, which is where a lot of people think they are. They're in the multitude of contractors that are working for the energy company. All those skill sets that are very, very important to bring to the table as well.
Wes Smith is a welding engineer for Appalachian Prefab, a Montoursville, Pennsylvania company specializing in natural gas pipeline fabrication, installation, and repair.
Maybe you should sit there and weave back and forth a little bit to get the feel for what you're going to do and then do it.
It's one of numerous businesses created to support the large natural gas corporations operating in the region.
It wouldn't be here without it. The natural gas was really what sparked the opportunity to start a business like this. The demand before that for this type of piping wasn't really there, but now it's through the roof. Any mechanical piping that needs to be run to transmit something from one location to the other or go through some process is what we're involved in. Whether it be a compressor station, a meter site, a pipeline, anything of that nature is what we're involved in.
Appalachian Prefab hired Wes about 2 years ago to oversee its welding operation.
I'm responsible for welder testing. When we get welders, before we can perform any task, a welded article that's under code requirements, we have to have tested welders, meaning they have to take an entrance test and pass the test to code criteria. So I have to do the initial testing. I'm required to make sure all the welding procedures are ready and review drawings for the welding related issues and make sure that the welding, that we're going to be able to do it effectively with the processes that have been chosen. I look for what diameters, the grade of the pipe, meaning what mechanical properties it has. There's a code book that tells you this grade should meet these minimum strength requirements. And I look at that, compare that with what filler metal we're going to use.
High school ignited Wes's passion for welding after some agriculture classes exposed him to the craft.
I used to actually stay after school to weld because I liked it so much. It kind of annoyed the teachers because they had to stay later. There were sparks and fire, and it was exciting. I mean, it was challenging. That was the thing I liked the most. Is it always was giving me another plateau to try to reach or exceed.
Wes could have entered the welding workforce right out of high school. Instead, he earned a bachelor's degree in welding and fabrication engineering technology at Penn College.
The little bit of extra expense and time you're going to spend in your life on the front end, the career opportunities are multiplied 6 to 8 times. I mean, I wouldn't be talking to you right now without the degree I have. The welder is the one that operates under what the welding engineer tells them to do. So they get a weld procedure that would be prepared by a welding engineer. So the welder is going to perform the task of welding. The welding engineer is going to prepare and plan and give the welder everything they need to successfully complete that weld. Here, I am the welding engineer. I'm the guy that makes the decision. So that to me was very appealing.
About 60% of Appalachian Prefab's work for the natural gas industry is completed in the shop rather than at a well site.
We look at it, figure out what we can build in the shop, and build as much as we can in the shop, ship it to site, ready to go. All they have to do is put it together, make a couple connection welds, field welds we call them, and then bolt up connections if they're needed. I love the challenge of it. Every day I have a set goal for myself, but at 9 o'clock that goal is thrown out the window because there could be so many things happening. The most challenging thing of this job is managing all these things at once and looking ahead, because you're really given a lot of responsibility, because nobody's really looking over my shoulder to say, hey, do you have these welding documents done? I've got to make sure I'm 1 step, 2 step, maybe even 4 steps ahead of everybody else to have everything prepared.
And Wes loves that his preparation benefits the natural gas industry.
I'm very happy and thankful for an opportunity to work in the industry. I mean, this stuff is a big deal. I've never seen so much stuff that has to come together to get one little bit of natural gas to your house so you can have heat.
The majority of Wes's labor falls within the production stage, the third of 3 phases of natural gas development. Work actually begins long before a drill penetrates the Earth's surface. The pre-drilling phase consumes several months and includes geological studies, permitting, and land preparation on the future well site.
You're looking at the company coming in and doing the land work. So they've done the leasing, you're making the assumption they've done that already. They're coming in, they're building a road, they're building a pad, they're getting everything ready. That could take upwards of a couple months, depending upon the site and some of the other considerations there. Then they're going to come in and start the drilling process. That can have several steps to it as well.
The drilling phase for one well can consume several weeks, as various types of rigs and machines are required for the initial vertical drill work, the horizontal drilling, and the hydraulic fracturing of the shale.
And then you would move into the next phase, which would be the production of that well, which could last decades worth of time. Early estimates are that this could be a 20 to 50-year run on a lot of these wells here in Pennsylvania. And then at the end of the life of the well, when it's no longer productive, at that point a crew would come back in and plug that well with a special type of cement and mark where it is, and at that point then the well would be abandoned.
While the majority of natural gas jobs are found within the drilling phase, the development and maintenance of a well requires many diverse professionals.
Here in this area and in most parts of Pennsylvania, you're looking at about 420 different people that would be involved in the whole life cycle of that well over the course of time. About 150 different vocations. You're talking about high value type jobs, family sustaining wages as is often cited. And those wages could be paid here in Pennsylvania or they could be paid in other parts of the world.
It's possible for individuals to secure employment for drilling's more physically intense work without any post-secondary education. However, for long-term growth potential and career flexibility, higher education in the form of trade industrial certifications and 2- and 4-year degrees is recommended.
The more you bring to the table, the quicker and the higher you're likely to advance in your career opportunities or up the career ladder. So if you bring some of those technical skills and a company is hiring you for that from the get-go, they're going to move you along considerably quicker, and the pay opportunities would likely be higher. And I think it's important as we back up into the middle school and the high school years that teachers also understand that this is something that's going to be there for a long, long time. So the idea about helping to counsel kids as they're moving through that process is key.
Dr. Eric Albert is helping teachers get that message.
It's the idea that we have a defective design, manufacture.
The Associate Professor of Machine Tool Technologies and Automated Manufacturing is the lead faculty member for a National Science Foundation grant awarded to Penn College. Provided through the Advanced Technological Education Program, the grant supports efforts to align both college and high school students with natural gas industry careers.
The first area at which we're working is to enhance academic offerings here at the college in the way that would allow students to connect to the natural gas industry. So the idea isn't to create a new major, but rather to look at the needs of the industry and then look at our current curriculum across the college where it makes sense to add and enhance it so that it better helps students understand the career path and the technological needs of the natural gas industry.
The grant has touched about a dozen majors, impacting hundreds of college students.
He did for 11 and 12.
High school students getting a head start on college also feel its reach.
The second goal is to actually do enhancement of what we call dual enrollment, where high school students enroll for a college class in a particular major. They're paying far less for that class, which is a great thing because they can take a college credit at a very reduced rate. But it is the college class delivered in their high school while they're still going to high school.
The grant facilitates training of the high school instructors teaching the college version of courses and links the curriculum to natural gas careers. There are hundreds of high school students throughout a 14-county area in Pennsylvania who have taken dual enrollment courses influenced by the NSF grant.
This has been a really interesting ride so far. I mean, certainly to see an opportunity to have our students penetrate another part of technical work is wonderful. It's jobs for our students, it's better employment opportunities.
That's true because those students are earning technical degrees.
For long term, the growth potential is to have a degree because that will put you in technical positions that direct labor can't do. I think it also gives you more choices so that you have the opportunities. You could shift to another company, you could shift to a different industry. So that's a lot of flexibility.
Brandon Howe has taken advantage of the flexibility afforded by his bachelor's degree. He put his information technology credentials to work in both the nonprofit and manufacturing sectors before entering the natural gas field a year ago. Today, he is a senior IT systems analyst for Anadarko. Like his colleague Doug Martin, Brandon is based out of the corporation's Williamsport, Pennsylvania office.
My position really encompasses every area of whether it's pre-drilling, drilling, completions, final production. IT is there from day one when there's just trees and grass to the final day when it's kind of completed.
As a kid, Brandon enjoyed robotics and computers. Aptitude tests in high school pointed him toward an IT career. He earned an information technology bachelor's degree from Penn College while minoring in business administration and management. Brandon enjoyed his first 2 IT career stops, but couldn't pass up the chance to work in natural gas.
It was an opportunity to get in at the ground floor and really grow with the industry. Every discipline in the IT field is realized in the natural gas industry. You can walk in as a degree-seeking student, and there's internships that we show a lot of various parts of the IT field from our Global Support Center, which is staffed 24/7. There's positions like myself in the field where we support the technologies for various region, but there's also more specific professional IT areas which focus on the network design of the corporate organization, email, servers, application development, and then also all the various management positions in IT.
White-collar positions like Brandon's constitute about 25% of the natural gas workforce, according to the Pennsylvania statewide Marcellus Shale Workforce Needs Assessment. Brandon also reflects the increasing number of Pennsylvania residents who have become natural gas workers. The assessment estimates that 70 to 80% of employees were from out of state during the early stages of development. Now up to 3/4 of new Marcellus workers are residents of the Keystone State.
I oversee the Marcellus Shale region. I support all of the users and contractors for Anadarko for those regions and the offices. I also do project management and also projects like rolling out wireless communications and network to our field. This job really touches on every IT discipline, from networking to wireless to applications to programming.
That diversity is one of the main reasons Brandon knows he chose the right job sector for this stage of his life.
What excites me every day about this career in this industry is that it is very different and it's very dynamic. We're all interconnected. We need each other in order to do a lot of the jobs, and at the end of the day, in order to extract the natural gas out of the ground, it really takes a complete team of people in order to do that.
That team includes automation technician Doug Martin. After reviewing numerous readings transmitted from the field to Anadarko's office in Williamsport, Doug is beginning the favorite part of his day at a well pad a half-hour away. Nature, rather than 4 walls, constitutes his preferred office.
The thing I like best about my job is just being outside, enjoying the beautiful days, seeing the scenery around me, being able to work in the element.
Doug has plenty of opportunity to do so. He spends hours each day at well pads calibrating and ensuring proper instrumentation.
I'm not actually fixing a valve or doing anything physical to the well itself, but my troubleshooting that I do is localized within the instrumentation itself. On this pad we have 5 wells which are currently producing gas and flowing into our pipeline. These piping sticking out of the ground here, that's where the gas actually flows out of the ground from the shale beneath, which is then carried by pipeline underneath the ground here over to our separators behind us. In the separators, all the waters and impurities are separated out of the gas. The water and everything that's separated out is put into our containment tanks over here, which have double containment measures for safety. Then our gas, once it's dried out, is sent to the dehyes which further dries the gas and gets it ready for your home for home use. As you can see, there's a lot of instrumentation. There are a lot of electronics and measurements. With as much instrumentation as there is, as many sensors as there are out in the field, there's usually always something that has gone down or kind of comes out of calibration. So it's very important to try to get to as many issues as I can throughout the day and fix them as soon as possible.
Doug's main tool to fix issues is a total flow computer, which serves as a controller for the well site.
Each well has its own input, output. So here I can see our first well. It's got 700 pounds on the tubing pressure. It's got 1100 on the casing, etc. 60 degrees is the temperature of our gas. We can see what our flow rates are reading here on this pad. We're seeing 3.6 million cubic feet currently. You can see the temperature, how much energy it's producing, what the battery is reading. Pretty much any troubleshooting I can do, I can see the symptoms inside the total flow computer here.
This visit requires minimal troubleshooting, which leaves Doug looking ahead to the next challenge.
Every problem that we have on each site is a different opportunity, a different challenge, and personally I love the challenge of the problems that we face out here, and the satisfaction of fixing it up is what I live for out here. When I come to work during the day and I can troubleshoot a problem and successfully figure out what's causing the issue and make the repairs necessary, I can go home at the end of the day feeling the satisfaction that I did make a difference out in the field, and that because I did my job, they can now read their values that they need to see to prevent any kind of issue that they could have out in the field. So we'll go to the next site and take a look at what that work order has and see if we can't fix that one up too.
Doug's workday has many hours remaining, but like Wes Smith and Brandon Howe, he relishes his time on the job. And he hopes many more dedicated, hardworking, and resourceful individuals with a technical background join him in the future.
It's a perfect opportunity, and now is a great time to jump on board with it.